viewers, good day. This is the third lesson on stoichiometry. So now here we are going to discuss about a number of moles, on how we can calculate number of moles given the volume, and this should be decimeter cube. So what we do here, first thing, we need to understand that we have this formula, which is number of moles is equal to volume, decimeter cube, then molar volume. So now this molar volume is always given in that information. So one, it can be let's say maybe if they'll say that the gas, maybe the gas of that volume, the gas of the volume is at we say STP, let's say STP, which is a standard temperature, pressure, standard temperature and pressure. So at STP, the molar volume that we use, so I'll just say it's Vm, I'll say Vm, which is molar volume. Here we use, it's 22.4 decimeter cube, 4 then more per decimeter cube. So this is the one that we use. This is the one that we use, which is the molar volume. Then apart from this one, let's say we also have what we call at RTP. So RTP, which is room temperature and pressure. So this one, the molar volume, always this molar volume will be 24 more per decimeter cube. Yeah, so we will have some, so we need to know when they say at STP we use this one, at RTP we use what? This one. Okay, so now let's see, try and see on how we can answer this example here. So this is the example that we have. So now this example, the question is calculate the number of moles of carbon dioxide present in 10.25 decimeter cube. This is decimeter cube, which is the units of volume, decimeter cube of carbon dioxide at STP. So here at STP, remember we've said that, so the formula we say that it's, we'll say the number of moles, which is, we'll just say number of moles. So let me again repeat to say number of moles okay, is equal to volume. So this is the volume that you'll be given, or the volume that they may ask you to calculate. So volume, this volume, let's say in this case it is in decimeter cube, because of what? So it is in decimeter cube because of the molar volume. So again we have what we call molar volume. So in this molar volume, we'll say molar volume. Okay. Molar volume, which is more decimeter cube. Yeah, so they will say small per decimeter cube. So you can include the brackets if you want. Okay, so we have something like that. So now in symbol, or in simple terms, you can just write like this. So N, which is representing mole, then there we just say volume, then this side you say Vm. So this M represents the molar volume. So we can calculate what you have asked. So here in the question, the volume that we have been given is this one, which is 10.25. So 10.25, it's the one that we're going to replace there on top. So we'll say as the numerator, which is 10 0.25. Then by which is 22.4, which is at STP. So now this one into this, how many times can it go? So there I see 0.457589 so we are going to round off to 3. So like this, more, so that is the unit. So here what it is, for you to write this unit, let's say, let me just include, so here we've got this meter cube, and there we've got more per decimeter cube. So this decimeter and this decimeter will do what? Will reduce to 1, but you cancel out. So you remain with what? This more is the one that I've indicated there. So giving the final answer, let's say, to 2 decimal places. So giving out 2 decimal places, you say it's going to be 0.4. Then this and this, it will give us what? This there, it will give us 6 more. So this is it is moles. This is in what? 2 decimal places. Then writing these 2 decimal places, let's say in scientific notation, so which means you can just move this point to this side, so that it can be 4.6 times 10 to the power -1 moles. So you can also leave your answer in like this, which is in scientific notation. Thank you on this one. So let's again go to the next question. This is the second example. So now on this one, the question is, what is the volume occupied by 8.00 gram of oxygen gas at STP? So even this question is at STP. So remember, the volume, which is molar volume, is equal to 22.4 decimeter cube. That is the molar volume. Molar volume, decimeter cube per mole. Yeah, so this is the molar volume. Now, what we have here, remember, see what you have been given. Which formula are you going to use? So there is a mass, and what you have been given, or what you have been told to calculate, it's the volume. The volume of this oxygen. So it's oxygen gas. So if it's oxygen gas, remember I said diatomic, so it means it will be O2, like this. So here to find the molecular mass, we'll say it's what? It's 2 times 16, which will give you 32. That is it. So now in this case, since the molar mass, in this case it is mole per grams. So this is it. So first thing, we're going to calculate the moles. So we say mole formula is N. Mole is equal to mass, then over molar mass. Molar mass, and this is the molar mass, and here the mass, it's this one. The mass that you have been given is this one. So let's see on how we can calculate. So the mass there, we say it's what? 8. Then over 8 grams, sorry. Yes, over we've got 32. So over 32, which is 32 grams per mole. Okay, grams per mole. So what happens here, you cancel the gram, you cancel this one. Then this into this, so your answer is going to be what will be your answer once you divide. So once you divide there, your answer is going to be our n is equal to 0.25 more. So this is your answer. So having this as your answer, having this one as your answer, this is just a mole. But in question, what we have been asked is to find the volume. So now, since you've calculated your mole, then it will help us again to calculate the volume. So you write the formula, which is N number of moles is equal to volume, then over molar volume, which is Vm, like this. So what you do here, you just replace here. What are you going to write there? So here you write 0.25. You write 0.25. Then so in other ways, you can just multiply to make V subject of the formula. So it will be V is equal to N times Vm, like this. So having this, we'll say, so where there is N, you replace by 0.25 more. Then times, remember it is at STP. And at STP, we say that it is a standard G temperature and pressure. This one, so we get this as your value on what? The molar volume. So you get this as a molar volume and replace here. So it's going to be 22.4 decimeter cube per mole. Okay. So then you reduce this one and this one. More will go. Then what you're going to remain with is just what? The decimeter, because volume, it is in decimeter cube in this case. So once you multiply 0.25 by 22.4, your answer is volume is equal to 5.6 decimeter cube. So this is your final answer. Then you are done. Okay, thank you. If any question, please do not hesitate to ask.